Awesome. So yeah, I'm Cellan. I'm a data scientist here at Habu. I must pre-warn you, I don't know anything about PHP. I code in Python. So I hope you can still take away some things from here and apply it to your work in some way, shape, or form. So yeah, let's get straight into it. So what is NLP? Well, basically, it's a subsection of AI and is often used in data science or any text analysis or machine learning. And it's just a way for computers to understand human linguistics. So some examples of this you use every day. Speech recognition, so Siri and Amazon Alexa, they have to understand what you're saying and then give you some sort of response back, and they usually perform an action. We also have Google Translate, and this is amazing, is being able to connect people all the way across the world. We also got your Gmail spam detection, so you can classify whether an email is just a bunch of rubbish or it's something important from your manager. And then we've got sentiment analysis, which is basically judging emotions from text. So this could be used for like an office satisfaction survey and really know what your employees are feeling from what they're writing in their feedback. So text-based NLP is what I'll talk about mainly because that's what I do in my job, and a speech is just a whole another bucket of fish that I don't want to get into. And there's a general pipeline, process and pipeline on how to change raw text into a numerical format which can be used for analysis or machine learning. So these are like the 4 steps that I'm going to cover today quite broadly, but hopefully you'll get an idea. So tokenization we'll jump into first. So yeah, here is some lovely Python code. I'm so sorry, but it's basically right in English, so you'll understand. So in tokenization with text, you want to split it up in some way, shape, or form. Now here, I've used this package called Spacey, which makes life just really easy. And you can put your text into one of their machine learning models, and it will know what each token of that sentence is. So as you can see here, Apple is looking to buy a UK startup for 1 billion. Unfortunately, that is not Habu. But you can see it's split up. Apple is looking at buying UK startup, and then you got the $sign, the numerical number 1 and billion. But you can also tokenize via sentence, say full stops or punctuation or like whole paragraphs. It really depends on your use case, to be honest. So after you've tokenized your text and you can access each token, you can do an element of cleaning. So the whole purpose of trying to clean text, machines, it's really difficult for machines to understand context of a sentence. So basically you just want to try and limit the amount of noise or just rubbish within your text so the computer can just really just get understanding from the most important parts. So this little print statement here will produce this nice little table. So the first thing I'm going to talk about is the raw text. So that's basically what I showed before in the print statement. And from the raw text, we can then get the lemma of the text. Now, this is basically a method of transforming words into its colloquial form. So if you were looking up something in the dictionary, say for example, if I had text which had swimming, swim, swam, swum, all in the same sentence, it would just change the word to swim. And this will help, like, if we want to increase the frequency of words within text and see, okay, well, like what are people actually doing for activities, and instead of having separate words which all mean the same thing, we could just have the one word swim. I hope that makes sense. The next one, we also have part of speech. So each word has a part of speech tag, and depending on analysis, we may just want to see, okay, what proper nouns are in this piece of text, or maybe we want to remove completely verbs from the text or numbers, and Spacey the package Spacey allows you to do that really easily. Next, we want to see if the word is numerical or not. So if we're training a machine learning model, a lot of the times you don't want to put numbers from text straight into it, because we don't want to model the learn patterns from specific numbers that really don't have any meaning. So we can easily remove them this way by a simple Boolean. And finally, stop words, probably one of the most important when it comes to text cleaning. So a stop word is basically words like the, at, and, everything that helps us understand the sentence and the context of that sentence, but they don't really mean anything in our analysis, to be honest. We want to focus on the most important words in there. So we could easily get rid of the words for, and is, and just keep the ones such as buy in UK startup, something that the sentence is actually trying to portray. So after cleaning the text, we now need a method of changing the text into a numerical format for any analysis or machine learning, because you can't just shove raw text into machine learning algorithms. So here is an example of a word embedding. This is from the Spacey's machine learning model. So it is the numerical form of the word banana. So you can also have simpler text transformation techniques, such as just a simple count of each word that is there. But yeah, this is a very powerful technique, as you're able to look at the similarities between words as well. So, for example, king and queen, the words will be very similar together rather than the king and cheese, and that can help in certain analysis depending on your use case. So how does this all come together? Well, I thought I'd try to make this a little bit more back-endy API stuff for everyone here. So first, in our machine learning project, we collect and analyze data and see if machine learning is a viable option. Next, we have our pipeline. So this is where we would load the data, like the raw data, for example, if we're using NLP here. We would process it, tokenize it, clean it, do everything to make the text into a nice format that we can then train the model. And then once the training process has started, we need to evaluate that model in some way. Basically, just to say, is the model actually giving you good outputs that you can rely on, or is it just spitting out a load of rubbish that doesn't mean anything at all? So once you're happy with how the model is doing, oh, sorry, I forgot. In this process as well, we have a meta database where we log different parameters. So as you see from the previous slide with the table, I might want to change how I do my text processing. I might want to remove stop words for one machine learning model training process. I might want to keep them in the next time. Might want to remove numbers one time and keep them in the next time. And this metabase of just logging all of these parameters and what I've done each time allows us and my team to just keep track of what we're doing and how the model is, what kind of results are coming from that model each time. And so once we're happy with the model and the output that it's producing, we then store the trained model in some sort of storage. So this could be AWS S3 buckets or Azure Blob, something along the lines of that. And once it's there, it could pretty much be used in any application. So for us, once we have a trained model, we'll create an API where that model is loaded in, and we have an endpoint where people can just access that and get predictions from that model relatively easy. So as an example, one of the projects we have ongoing here is categorizing items that Habu sort of sells for its customers. And we have made a model so you can put in an item title, like the title you see on Amazon or eBay, and it would give you back a product category, like a Habu product category. So whether that would be like home and leisure or an entertainment item, something like that. So the wider business can actually interact with this machine learning model. And that's where the inference comes from. So you want to predict what this item would be, and get analysis, and then from those predictions you can do some different analysis with that data. And then also finally, the final connecting cycle is from this inference. Over time we will do a check to see how the model is actually performing in real life. This is quite a difficult part of the machine learning process. It can't always be automated, but simply you could choose a time at the end of every month or a certain time period where you would see all of the predictions that have been logged in some sort of SQL database, and then to just do a manual check, like, okay, is it actually predicting what it should be or not? And if it isn't, then we would start this whole process again and then use more data to train a model, or we might just keep it as it is, until it does need changing at some point. So yeah, I hope that was a lightning enough presentation. Thank you all for listening, and yes, it's a lot to cover in 10 minutes, so if you have any questions, feel free, go ahead now. But thank you. Yeah. Oh, sorry.
Yeah, brilliant. And when you talk about the vectorization and like how it knows the difference between like king, queen, and like, how does that fit?
Okay, so that is a presentation all in itself. But simply, it's a way of like just taking words and giving them specific coordinates on a 3D plane, and then you can use cosine similarity to see what the distance is between those coordinates, and if they're closer, if the angle is closer together, they're more similar. If they're further apart, they're less similar, more dissimilar. But yes, that's a whole nother presentation. We can catch up on that some other time. Yes, Emily?
Yeah, so for example, with like, I don't know, internet speak, like I guess sentiment analysis is a bit tricky when you have like non-standard, like English, for example, like people using slang or like abbreviations. So yeah, how best would you manage that?
So that is a very tricky part of natural language processing, and there is an element of having to correct text before it goes through this sort of pre-processing pipeline. A lot of the times I was previously in the MOD, and we would have a lot of acronyms in the text, and I would have to expand them out and things like that, or try to correct misspellings. There are certain packages that can help you assist with that. But these language models these days are so good that they're already pre-trained for those kind of situations, so they help out a lot anyway. Anyone else? I know it's late, so you probably all want to go home.
So the same kind of approaches work across different languages, like obviously this is different in English is down.
Yeah, sure. So I use obviously an English example here, but Spacey as a package itself can do a lot of European languages as well as Mandarin. It becomes a lot more difficult because even tokenizing a language which isn't a native Latin one, so Mandarin, like you can't easily use the delimiter of a space to tokenize each word, kind of thing. But there are many guys who are much smarter than me who have done all of this in the back end of their code. So I could just have the fruits of their labor in my analysis and machine learning. So yeah, it's definitely possible, but it's an ongoing challenge that people are working on. Sure.
Are there any like good online APIs that do this for you? Just need it to start.
I haven't really tried any APIs as such. Potentially, Spacey can integrate with other languages, not only Python. But I'm sure there's stuff out there depending on your use case.
AWS as well as service.
Yeah. So it really depends on how customized you want your sort of processing of text to be. To be honest, for us in the data science team, it makes sense just to use a package and write our own helper functions for all of this. But someone in other teams that don't really do our role but need a similar thing, yeah, there's services available for sure. But I'm not sure off the top of my head because I just code it myself. Yeah. Anyone else? No? Okay, cool. Thank you, guys.